We know that we want to find this rate of change of temperature with respect to time. So we can collect the remaining terms and then solve for d temperature, d time. Now let's take an inventory of what we know. Density and specific heat are given. Thermal conductivity is also given. And the generation rate is also given. Now this only leaves this temperature gradient dT/dr. For this problem, the key word in the problem statement is that the heat generation rate is suddenly increased. So we're being asked to find the initial rate of change of temperature with time. That means like right at the instant when this heat generation rate is increased, when the heater is switched on or switched to a higher power, right at the instant after which that happens, we want to find the rate of change with time at that point. Because that happens right when the temperature is changed, then it's reasonable to assume that the temperature distribution, the T as a function of R that were given in the problem originally in part A, still exists. It's going to change from that point onward, but right when the temperature is changed, we know, if we believe that we assume that that's the temperature distribution, then we can solve for that. We can use that to find the temperature gradient. That's the strategy here. We'll use the temperature distribution that's given in part A to find dT/dr, and when we do that, everything else is given, so that will allow us to find this initial rate of change of temperature with respect to time at various locations within the rod.